This question is to calculate the work required to pump water out of a tank. Please subscribe to our YouTube channel Math Tutor 8285. Your subscription fuels the passion. Let's grow together. Copyright all rights reserved. Thank you so much. A tank is formed by rotating the curve defined by x squared plus the square of y minus 1 equals 1 for y between 0 and 2 around the y-axis. The tank is filled with water of density 1,000 kilograms per cubic meter up to the top. How much work is required to pump all the water out over the top edge? Take g as gravitational acceleration. There are 4 options. First step, we identify the region. The curve is a circle centered at the point 0, 1 with radius 1. Rotating around the y-axis gives a spherical-shaped container spanning y from 0 to 2. Next step, cross-sectional area. At a height y, the radius satisfies r squared equals 2y minus y squared. So the cross-sectional area is pi times the quantity 2y minus y squared. Then, next step, we work for a thin slice. At a given height y, the slice of water must be lifted 2 minus y meters. The small amount of work is water density times g times the slice volume times the lifting distance. That is 1,000 times g times pi times the quantity 2y minus y squared times dy times the factor 2 minus y. Next step, total work. The total work is 1,000 g pi times the integral from 0 to 2 of the quantity 2y minus y squared multiplied by the quantity 2 minus y with respect to y. After that, next step, we simplify the integrand. Multiply out the expression 2y minus y squared times 2 minus y equals 4y minus 4y squared plus y cubed. Next step is to compute the integral. The integral from 0 to 2 of 4y minus 4y squared plus y cubed is equal to the expression 2y squared minus 4 thirds y cubed plus 1/4 y to the 4th, evaluated from 0 to 2. Plugging in, we get 8 minus 32 over 3 plus 4, which equals 16 over 3. Next step, we multiply constants. Finally, multiply by the constants. 1,000 g pi times 16 over 3. The answer is 16 thirds times pi times 10 to the third times g. So the correct choice is option B. Always, first find a radius function, then compute the cross-sectional area, multiply by water density and gravity, include the lifting distance 2 minus y, and integrate carefully. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Copyright all rights reserved. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Your subscription fuels the passion. Let's grow together. Thank you so much.